All right, this video we're going to look at reflection transformations. So the first thing that we need to keep in mind about reflections is that it's just a law of physics, or just from observation. What we know is about mirror images is that this distance is the same as this distance. Namely, um, when you stand in front of a mirror and if you're looking at your reflection, how far you're from the mirror is the same as how far the image is from the mirror. So that's the basic idea that we use. And the two main reflections that we study. So when we say reflection, we have to assign a mirror, right? What is the mirror? So there can be reflection. So we can either have reflect on x-axis, or we can have reflect on y-axis. Now these are not the only reflections, right? You can reflect around any line, you can reflect anywhere, but these are the ones that we will begin with talking about because these are the most simple ones. So reflecting around x-axis would mean a graph like that would switch over and become something like that. Okay, and these distances would match up. They don't look like so in my graph, but they're going to match up. Similarly, a graph like that, when you reflect on the y-axis, would become like that. Okay, so we got to figure out now algebraically what is happening. So let's see in the first one. What is happening is, if I take this point A and I go up, then this is A comma f of A. But if and this distance is f of A. So the reflection should have the same distance, but now it's in, once you reflect on the x-axis, it goes to negative y. So this point becomes A comma negative f of A, which means that reflection on x-axis just means you take the function and you make the output negative of what it was. So if the output was originally positive, it becomes negative. If the output was originally negative, it becomes positive. Whereas in this case here, what's going to happen is, if this is A and that's my height f of A, then this distance remains the same. So this distance is A, which means this is going to be negative A. So in this case, you're changing x to negative x. What you're saying is, whatever the function does for positive inputs, now it does the same for negative inputs. Or whatever the function did for negative inputs, now it does for positive inputs. Okay, so let's look at two examples. Let's say you have to plot the graph for negative x squared, and then you have to plot the graph for square root of negative x. So the way to go about it is, you start with x squared and then you go negative x squared. Now x squared, you know, is that negative x squared means you're reflecting around about the x-axis. So reflecting about the x-axis gives you that. Similarly, in the second case, you start with square root of x and then you make it square root of negative x. Square root of x, we've seen, it looks like that. Now changing x to negative x is a reflection around the y-axis. So that would be square root of negative x. Okay. Now for example, here, if I change, in the first example, if I were to reflect around the y-axis, that would be negative x squared, which gives me back x squared. And you can see that if you take the x squared function and you reflect it, you get it back. Right? It doesn't work out in that case. So again, there are some functions which, when you reflect them around x or y axis, may or may not change. And towards the end of the material, we will give special names to these special functions. That brings us to the end of the reflection part. This one's pretty simple. The last transformation that we need to talk about is called it's stretching and shrinking. So we're going to look at that in the next video. And once again, just with everything else, there's going to be two categories of stretching and shrinking. There can be a vertical stretching, shrinking, and a horizontal stretching and shrinking. All right, that's it for this video.